Good morning, students. Welcome to Channabasweshwar IIT JEE online classes. Myself, Shekhar Gouda. So, I will continue chemistry. In last week, we had discussion on basics like knowing atomic numbers, atomic masses, and electronic configurations, and writing formula of all ionic compounds from crisscross method. This is what we had in last week, and later we know the classification of elements by different scientists, how they classified elements and how this classification developed from different scientists and their concepts. This is what we had discussion in that element classification. So main important classification is long form of periodic table. So currently whatever the periodic table we are using based on electronic configuration. So according to latest classification, physical and chemical properties of the elements are periodic function of their electronic configurations. So if you want to know the physical and chemical properties of elements, you need to know the electronic configuration. Without knowing electronic configuration, it is difficult to predict and analyze physical and chemical properties of the elements. Once you know the electronic configuration of a element, or if you know the electronic configuration of elements which are in the same group, then you can predict most of the properties. So that's why, knowing electronic configuration is very, very important. How you can write electronic configuration based on atomic numbers. After knowing the atomic numbers, based on what energy diagram means, Molar diagram, so energy order of orbitals, that with respect to energy order you can fill the electrons in the orbitals, then resultant you will get electronic configuration of corresponding atoms. Okay, whatever the respective atoms, you will get the electronic configuration. So without knowing electronic configuration, little difficult to understand most of the basic things in chemistry. Okay, please try to know the all electronic configurations, okay, in the long form of periodic table, which is latest classification. Right, now this is what we had in the last week, and paper discussion also over right now. So today in this week mainly we will concentrate on mole concept. So this concept is very, very important to understand most of the chemistry basics. So you can say that this is one very important key concept to understand chemistry. Right, now before starting mole concept, so let me give the introduction. What is the importance of mole concept, and why we have to take mole concept, how mole concept is more important in chemistry to understand the chemical reactions, especially. Right, now here in the nature, whenever you have in the nature we have different type of matter, means there are different kinds of states of matter exist in the nature. To measure this different kind of matter, you need to have some measurements. Like in physics point of view and chemistry also, in science point of view, you will be having the units and dimensions. So by using units, you can measure the quantity of the substance or quantity of matter. So in terms of what? In terms of what? Weight means kg and grams. In terms of length, centimeter, meter, kilometer. These are what? In terms of what? Pressure, atm, bar, dynes, pascals, okay, torselli, okay, the centimeter, millimeter. These are what? Units of pressure. And to measure volume, milliliters, liters, and meter cube, centimeter cube. So these are what? Volume measurements. And energy, to measure energy, so you will be having calories, joules, electron volts, ergs. These are what? Units of energy. So these are all units we are using to measure the substance. okay, to measure substance with respect to property or with respect to what need property. Right, now here, now in chemistry we are doing what we have to do the chemical reactions, or there are many chemical reactions are taking place in the nature. How reactions are taking place? Right now here there are reactants will react each other, resultant you will get the what products. When reactants are reacting, definitely you need to take some stoichiometric ratio of the components, then only you will get our required product and required quantity. So how much you want to prepare the product, so based on that you need to add required reactants with some need of ratio. So every reaction has its own ratio, that whatever taking ratio is said to be stoichiometric ratio. Whatever the ratio is said to be stoichiometric ratio or balanced ratio. When you take the balanced ratio of reactants, then you will get what you will get product with a required yield. Okay, our whatever need is there, so that amount if you want to get it, you need to add the reactants with respect to stoichiometric ratio. Right, now my question is, in the nature we have atoms and molecules. Okay, so atoms and molecules, for example, if I have it iron, if I take iron metal, in that there are many iron elements, means atoms will be there. Now I want to take iron, means how I have to take it? So in terms of what, if I take it weight, so weight always it will give the what wrong yield it will give. If you take it weight, it will not work out always. Okay, next if you take it means depends on reaction, weight method is not applicable. For example, so always you can't take the weight ratios, simply we are mixing, for example, two things. In case of physical need, physical mixing you can apply general things like weight, but here whenever there is a reaction between two things or two atoms or two molecules or two reagents, you need to have it stoichiometric ratio with respect to mole only. Right, now what is a mole? So mole is nothing but one number, like in the nature. So for example, if you want to eat banana, so then you will go and you will go to market and you will ask like I need 1 dozen banana. 1 dozen means what? 12 is the number. So dozen means automatically, so that person will give what? 12 bananas he will give it. That means whenever you are saying dozen, means 12 is the number, is the count. So 12 is the number, that is what the dozen. Like that in chemistry also, so there is a concept of mole. So when we take mole, so mole is the one number always which will give molar mass of the component. Mole of that 1 mole of particles, mass will be equals to always molar mass, is said to be what? Molar mass. With respect to atoms, atomic molar mass. With respect to molecules, you will get molar molecular mass or molecular weights. With respect to salt, formula means molar formula weight, that is what? Salt. Next, with respect to ions, if you have the 1 mole of ion, then ion molar mass. So molar mass, here we are, whenever you are using molar mass, means mole is the one unit, mole is the one entity to measure the number of particles in the substance to carry chemical reaction, to run the chemical reaction. Right, now earlier already you know that some basics, like we have the small atoms, like atoms means atomic mass units, you can use it. For atoms case you can use the atomic mass unit. So atomic mass unit is not a particular unit, it is just number. So okay, just number we are taking. So this is what weight of atoms. Actually experimentally you can find weight of any atom with respect to carbon C12 isotope, actually from the mass spectrometry. So there is one spectrometry, mass spectrometry. If you put the sample in the mass spectrometry with respect to carbon C12, it will give the what is the mass of atom. So you will get it from experimentally. Okay, right, here carbon 12 is the reference. Okay, you can take it as reference anything, but you can take it hydrogen also reference. With respect to hydrogen, how many units it will be more, then that what is the mass of atom, we will take it. Right, now let me start first atomic mass unit. What is atomic mass unit? So atomic mass unit nothing but mass of one atom, that is what atomic units. AMU is nothing but atomic mass unit. So atomic mass unit never be fractional, it's very very important. atomic mass unit never be fractional. It is very, very important. So always it will give some integer number. Earlier we have, for example, chlorine is there. Chlorine atomic mass, if I ask 35.5, you are saying what? 35.5 is the grams per 1 mole of chlorine atoms. So that weight you are getting from the isotopes. But atomic mass never be fractional. Why? Because you are taking mass with respect to one atom, means with respect to one isotope you can take it. So chlorine will exhibit 37 AMU is the one isotope, and 35 AMU is the another isotope. This is what AMU. Now let me start and how we can find atomic mass of different atoms. Now let me discuss. Right, before starting mole concept, first let me take it simple things are what? Atoms. After knowing the atoms, then we will talk about molecules. Right, atom. So for atoms, mass of atom is said to be atomic mass unit. Atomic mass unit. Right. For example, here atomic mass unit is the very simplest unit, and very small microscopic unit. Atomic mass unit is the smallest and microscopic unit related to only one atom. So this is what you need to understand. So mass of atom, we are talking with respect to one atom only. That what unit will be atomic mass. So this is what you can write it AMU. This is what AMU. So whenever you are expressing atomic mass of any atom with AMU, indicates there is only one atom, its weight will be given with some number. Right now let me take it here hydrogen will be there. If I have it hydrogen, okay, here I will take it atom and atomic mass units AMU, how much you will get? Atomic mass unit will be equal to number of protons plus number of neutrons. This AMU you will get from the protons and neutrons only you will get. Right, atom is, for example, hydrogen if I have, it's is equal to AMU. It is what? AMU. And if I have helium atomic mass equals to 4 AMU. Next, if I have sodium will be 23 AMU. And next, potassium, if I have potassium, 39 AMU. And next, calcium, if I have calcium, 40 AMU. And silver 108 AMU. And next, if I have copper or zinc, okay, there are what above 30, little difficult to know the atoms. Right, now atom. Right, here one hydrogen atom weight will be equal to 1 AMU. One helium atom weight will be equal to 4 AMU. One sodium atom weight will be equal to 23 AMU. One potassium atom weight will be equal to 39. One calcium atom weight will be equal to 40. One silver atom weight will be equal to 108. These are what? Atomic mass of atom will be measured with atomic mass unit. This is what one atom weighs. Right. Now actually taking AMU, it's very difficult. Actually practically it is very difficult to weigh one atom. Actually atoms and molecules are what? You can't see the atoms and molecules. They are invisible in the matter. You can see the only macroscopic bulk quantity of matter only you can see that. But from the matter, if you separate molecules and atoms, you can't see, we can't see with our naked eye. So that is the reason why. So without seeing that what, how you can measure one, that what AMU, that means it is very difficult to weigh the one hydrogen atom. This is what just idea to with respect to reference given by Avogadro scientist, given by, there are many different scientists, but Avogadro is the well-known scientist. He gave concept of mole. So from that, so we are right now we are following mole concept according to Avogadro scientist only. This mole concept only we are following, and we are doing many chemical reactions with respect to mole ratio. That is what stoichiometric ratio. Right. Now here getting weight 1, 4, 23, 29, 39, 40, 108 AMU, it is very difficult to weigh. There is no instrument to weigh 1, 4, 23, 39, 40, 108. So right, then it will be a little difficult. Now if you convert this AMU into grams or kgs, then easily you can weigh it. Now if I convert, so grams means 1 AMU will be equal to by Avogadro number. Right here, let me give it so mole concept. First let me give one point here. Mole concept will be proposed by Avogadro's scientist, according to Avogadro's, then there will be a Avogadro number, which is what Na, which value is equal to 6.022 into 10 power 23. This mole concept, whenever you are talking 1 mole is nothing but which is the substance. Whenever it is talking 1 mole means in that there are Avogadro number of particles. This Avogadro number value will be equal to 6.022 into 10 power 23. Like 1 dozen, how you are taking 12 number. Same way here, whenever or wherever you are talking mole idea. Mole means indicates these many number of particles will be present in that substance, whatever you talk it. Atom means atomic particles, molecule means molecular particles, ion means ionic particles. If you talk about electron means electrons particles, proton means proton particle, neutron means neutron particle. You can take anything with respect to mole. When we are using mole, 1 mole of electron, 1 mole of atoms, 1 mole of molecule, 1 mole of ion, this is what the number you need to think it. You need to get it. This is what the value, this is what the number of particles we are using in that particular requirement. Okay, right. Now this is what the number right now. Now I will be having AMU is the what with respect to 1 atom I have. So AMU, whatever atomic masses are there, that is what 1 AMU is different. 1 gram is the 1 mole of hydrogen atoms weight. So earlier, so whatever the masses will be given in the periodic table, all are calculated with respect to what we are taking grams. Grams means 1 mole we are taking. If we take 1 with respect to 1 atom, you have to use the AMU is AMU if you use that is what for 1 atom. Okay, right. Now 1 atom weight will be equals to 1. Then so what is the gram? So if you want to convert gram, then you can take it. So this is what which is equals to 1 by 6.02322 into 10 power 23. So then what will get here? So here what 1.66 into 10 power minus 24. This is what the grams. You will get grams. Right now here 4 AMU. If I want to convert, this is what weight of hydrogen 1 atom weight in grams. Weight of 1 hydrogen atom weight will be equals to AMU by Avogadro number. If you take it, then you will get what weight of 1 atom in grams you will get it. Right, same way helium weight will be equals to what? Here helium is what with respect to hydrogen it will be 4 times. Then 4 into 1.66 into 10 power minus 24 grams is the weight of 1 helium atom. Weight of 1 helium atom in grams. In grams we can take it which equals to what 23 into 1.66 into 10 power 24 grams, and which is equal to here 39 into 1.66 into 10 power minus 24, which equals to 40 into 1.66 into 10 power minus 24. Here 108 into 1.66 into 10 power minus 24 grams. These are all grams. Okay, grams. Grams means what? 108 into 1.66 into 10 power minus 24 grams is the weight of 1 silver atom. Right. Now, my intention is I need to have it 1 mole of atoms. 1 mole of atom. 1 mole of atoms which equals to molar mass or molar atomic mass. Molar atomic mass means here 1 mole of atom mass we are talking means 1 mole of atoms mass. 1 mole of atoms mass means molar atomic mass, means indirectly you will be having these many number of particles weight. You know that, for example, I have what? I have hydrogen. Example, hydrogen is there. For hydrogen, I will be having here 1 by here Avogadro number. So this is what for one hydrogen. If I have Avogadro number of particles, then Avogadro number will be get cancelled. Then I will get what? 1 gram. So this is what 1 mole of hydrogen weight will be equals to 1 gram. Simple, very simple. Instead of AMU, if you write it gram, that is equal to molar atomic mass of atoms, means Avogadro number of atoms weight in grams. In grams you will get it. That is what, very simple. Avogadro number will be cancelled. Then you will get 1. This is what hydrogen. Same way with respect to other atoms also you can take it. With respect, if I take it oxygen. With respect to oxygen, what I will get? With respect to oxygen, here it will be equals to 1 by, means oxygen is what? 16 AMU by Avogadro number into Avogadro number. Then I will get 16 grams, I will get it. Just very simple. Whenever you are using AMU indicates weight of one atom. When you multiplied with this value, okay, so when you multiplied with this 1.66 into 10 power minus 24, then this is what weight of one atom in grams. Next, AMU. Instead of AMU, if you write simply grams, that indicates 1 mole of atom or molar atomic mass. That is what for hydrogen it will be 1 gram, for oxygen it will be 16 grams, for sodium, if I have sodium, so it will be what? 23 by, if you have it, you can take it. For example, here, earlier I have AMU, no? Right. So earlier I have AMU. If I want to convert into grams, means I have to multiply with 1.66 into 10 power minus 24 into what? Avogadro number. Avogadro number is what? 6 into 6.022 into 10 power 20 plus 23. This is what the Avogadro number. Then if I get it cancellation, then what I will get here? I will get what? I can get the cancellation. So exactly 1.6 into 10. Then so you will be getting 10 and 1 10 power minus 1 and this. Then finally you will get what? 23 grams. This is what basic idea. Okay. So right, actually nowadays we are not at all using AMU concept. So AMU concept little confusing for the students. So AMU, instead of AMU directly you can take it 1 mole of atoms weight will be equals to, these are the values. In grams you can take it. 1 mole of hydrogen weight will be equals to 1. Then 1 atom of hydrogen weight equals to how much? 1 by Avogadro number. So here also, here 1 mole of helium weight will be equals to 4 grams. Then 1 helium atom weight how much? Then 4 by Avogadro number. That what 4 by Avogadro number. Then you will get 1 helium atom weight. You will get 1 mole of sodium weight will be equal to 23 grams. 1 mole of sodium weight will be equals to 23 grams. If I want to know the only 1 sodium atom weight, then what I have to do? So here 1 mole 23 grams. Then if I divide with Avogadro number, then what I will get? I will get 1 sodium atom weight. I will get it. This is what the funda you can apply it. So like this you can get it atom mass. Okay, atomic particles, how many are there, I can get it right. Now let me give it when AMU is given, so you can find the number of particles. Now let me solve the questions, let me give the questions. And one more thing here, just here 1 AMU is nothing but, here I will give it 1 point, note point, basic note point. 1 AMU is equal to 1.66 into 10 power minus 24 grams, which is equals to 1 by Avogadro number. Both are same only. Which is this is what in grams you can take it. In grams, so which is equals to avogram, and this equals to 1 Dalton, avogram, 1 Dalton. All are same only. So 1 AMU is equal to, okay, 1 AMU equal to 1.66 into 10 power 24 grams, and which equal to 1 by Avogadro number, same only. This is said to be 1 avogram or 1 Dalton. So all are same only. Okay, all are same only. This is what point you can write it. Right, now let me give some questions. Okay, right here, let me give the question. Here question is, first question, find here. So I will be having here 200 AMU of helium. Now I will be weighted what 200 AMU value will be given. that is what with respect to helium. In this 200 AMU, there are how many helium atoms? There are how many helium atoms will be present? Now you know that one helium atom weight will be equals to 1 helium atom weight equal to 4. In 200 how many? Then do the crisscross method, means unitary method. Firstly you should know the standard basic values, then so you can apply the unitary method. By doing crisscross you will get value. Right now, so 200 AMU of helium contains how many number of in this, what this is what the data will be given in this. Find number of helium atoms, number of He atoms. This is what the question mark. Right here, if I have the 4 AMU indicates there is one helium. If I have 200 AMU, then it will contains how many? Do crisscross, then X will be equal to 200 into 1 by 4, you will get what? 50 helium atoms. 50 helium atoms. In 200 AMU, there are what? 50 helium atoms will be present. So whenever AMU is given, it must be whole number ratio. Okay, it must be some integer, not fractional. Why? Because number of protons plus number of neutrons will be always some number. Sum of this particle will be some number only will get. So whenever you are taking AMU, you should not get fractional. This is what you need to remember here. Right, this is what one question you can think it, you can solve it. In 200 AMU of helium, there are how many number of helium atoms? Then you can solve it. Right now, next I will be having in 230 AMU of sodium. In that there are number of sodium atoms. There are how many number of sodium atoms? Then I will calculate here. You can calculate here. This is what 1 sodium. Firstly, you should know that in one sodium atom is having 23 AMU. In 230 there are how many? So firstly you have to do it 23 AMU. AMU is equal to what? 1 sodium. If I have 230 AMU will be equal to how many? Do crisscross, then X value will be equals to 230 into 1 by 23, then which equals to 10 atoms of sodium. 10 atoms of sodium you will be having. This is what basic idea. So when AMU is given, you can find how many number of atoms will be present. You can easily find out. Okay, you can figure out from this what AMU concept. So AMU means with respect to one atom you are talking. If you multiply with number, you will get total weight of atoms. Right. Now I will give few more examples. Okay. Right. First, once again, let me explain here. Before applying mole concept, right? First, let me give it a mole concept proposed by. This concept was proposed by Avogadro scientist. According to Avogadro, 1 mole of substance, any substance, will be having these many number of particles. Here, particles may be either electrons. You can take it either electrons, or protons, or neutrons, or atoms, or ions, or molecules. Particle may be anything. You can take ion, atom, molecule, electron, proton, anything you can take it. Whenever you are talking 1 mole of electron means in that these many number of electrons will be present. 1 mole of proton means in that these many number of protons will be present. 1 mole of neutron. So 1 mole of neutron, in that these many number of neutrons will be present. So 1 mole of ion means these many number of ions will be present. This is what idea you have to keep in mind. This is what the standard reference basic value to understand the chemistry. Like dozen means 12 is the number how you are getting. You need to remember this Avogadro number value. Okay, you need to remember Avogadro number value. Avogadro number means that is what 1 mole of particles. Its value, mathematical value is 6.022 into 10 power 23. This is what here. What are the this particle number? May be anything in the nature. In the nature, what we have? We have electrons, protons, neutrons, atoms, molecules, ions. Okay, so combination of these particles only we are getting what all different states of matter we are getting in the universe. So that's why here mole concept you can apply anywhere, wherever matter is there you can apply mole concept, right? This is what general introduction. Right, now if you see the microscopic level of matter, in that microscopic atoms are the basic particles. Now with respect to atom, whatever you are getting is said to be what weight of atom, that is what measured in AMU, atomic mass units. AMU, with respect to AMU means whenever you are using AMU indicates with respect to individual atoms, individual atom, one atom weight equals to 1 AMU.